Here we have a figure that it says to rotate 180 degrees clockwise about the origin, then answer the questions. And the questions are true or false questions, wondering if the final angle measures are smaller than the original angle measures of this figure. And when the figure is rotated, if two sides are parallel to each other in the original figure, then those sides may not be parallel to each other. Is this true or false? In the final figure. And when the figure is rotated, its side lengths stay the same, true or false. So let's go ahead and look at this figure. We have a point here, a point here, a point here, and a point here. We notice that these points line up. They're on the y equals -5 line, and these here are the horizontal line on y equals -3. So here we see that we have parallel lines here on top and bottom, and what we're looking to do is rotate this 180 degrees, but we're going to rotate 180 degrees clockwise, so we're going in the direction the clock would go. We want to draw a line on our x-axis that's closest to, so we see here on top it's going to be closest to the figure, and this is what we want to rotate 180 degrees. Now normally when we have 180 degrees we're going to be rotating in the counterclockwise direction, but this specifically says clockwise, so we could write this a -180 degrees rotation about the origin. So if we had this point here and we put a pin through it and we were rotating about this point, we would rotate in this direction 180 degrees. So this line here, this part of the x-axis would become the new positive portion of the x-axis. And we can see what happens when I have my paper here. I have my tracing paper here. And if we put a line, if we put a pin right here, and this was our rotation point, and we wanted to just push that line and rotate it, and it would pull the object with it. And as we do that, as we rotate around, and then this becomes our new pivot point right here, or the pivot point stays the same, but this is our new line and our new figure. And we see again, relative to this line that we drew, the one that we rotated, the figure is constant in terms of this, these two points here are still 3 units away. They're still 3 units away from this line that we drew. Here are our new points, and I can go ahead and draw those in. So it's going to be at 2, 3, and at 5, 3. And then we also have 3, 5, and at 6, 5. So I'll go ahead and draw those in. At 2, 3 here, and at 5, 3 here, 3, 5, 3, 5, and 6, 5. And there would be our new figure. Now notice, we didn't even need to really draw this in order to answer the questions. Notice that we still have parallel lines. Nothing happens to the figure itself. The angles stay the same. The lines are still parallel because the figure does not get dilated at all. The angles don't, it doesn't get distorted at all. It's just rotating about a pivot point. So when it's rotated, final angle measures, are they smaller? No, they're not. If the two sides are parallel to each other, then the sides may not be parallel. No, that's not true. They're still going to be parallel because it does not get distorted at all. And when the figure is rotated, its side lengths stay the same. Yes, that is true.